Now that we have an account and PBR installed, we can go and try to set up our Raspberry Pi. As I said, the easiest way to do it will be inside your account, go to download image and select the device that you are going to be using. I'm going to be using a Raspberry Pi 3, and for that I will select the ARM Raspberry Pi 64 version. It's the 64 bits OS, and that will run either on a Raspberry Pi 3 or Raspberry Pi 4. It's the same image for those two devices. Or I can select the Raspberry Pi 3 or Raspberry Pi for a specific one in here, but let's go with the 64 that works for both devices. I can preset up here the Wi-Fi configuration, but because I am using the cable to connect the Raspberry Pi to the network, I won't be pre-configuring anything. This image is preloaded with the user credentials. Therefore, in the moment that the device starts, it's going to be pre-claimed by you. There is a way to download the image from the documentation from here, where you are going to download an image that is not prefetched with any user data, and it won't be connected to any hub account from start. And if you want to use the local experience, or only what we call Pantavisor, that is only the system that will run and can be updated and everything through using the same PBR CLI, but without going to the cloud, you can download the image from here in the documentation, as just I was saying. But because for this project I will be using Hub and the whole cloud infrastructure, I download the image from here with my credentials preload. In that way, the device is going to be connected to the cloud just after starting. After the image is downloaded, we are going to flash or write that in a micro SD card, and I'm going to flash this in here by using the flash USB flasher tool on Pop OS, but you can use the Raspberry Pi 1 or HR, whatever you know, DD, or whatever you want, basically. And I have I need to decompress this. After the extracting is done, I will just grab that and I will use my 16 gigabytes device to start the Raspberry Pi 3. It will ask me for as I said, I use the Pop OS USB flashing tool, but you can use the Raspberry Pi 1 that is somewhere. It's here in software, this one. Raspberry Pi imager is kind of the same. You choose the file that you want to flash, the storage, and write. That's it. It would take more or less the same amount of time, or you can use Etcher if you want, or do a simple DD to clone the whole image inside the SD card. Anything that you know or you are comfortable doing, just do it. I use this because it's already in the software, in the operating system, and I don't need to think more about it. As you can see, now we have two partitions in that device. One is the whole Pantavisor folders and the boot partition that has drivers and everything else. I will mount both of them, and I will remove it from the computer, set it up on the Raspberry Pi, set up the Ethernet cable and my power cable. Now we have this working, and I won't access it through any monitor or anything else. I will just go back to Hub, and the device will appear in a couple of seconds after the whole first boot finish. But now the first boot is finished. I have a new device here. Last seen a few seconds ago. This new device is the brand new Pantavisor running on my Raspberry Pi. You will find here information about the IP address, the model that is running, the architecture, and that kind of stuff. And one important thing is that if you want to do a SSH in your device to see how it's running or what is running, remember the Pantavisor runs containers. Therefore, it has 3 containers running right now. One is the AW Connect, that is a Debian based OS that has like all the network functionality and some nuisance. For example, if you are not connected to the Ethernet cable and you don't configure the Wi-Fi inside the Hub application, the device is going to start a hotspot that you can connect to that hotspot and set up the Wi-Fi network that you want to connect, like any other IoT device that you may have. Then we have the PB Avahi, that is a platform to broadcast the device information in order to be able to do PBR device scan here and be able to find the device in the network. And the PBR SDK that will allow us to interact with the device in a local form with PBR, like trying to push new updates, or if you enter via SSH, you will be able to run Pantabox, that is a tool for local development. But I don't want to go deep in that road right now. I want to continue with the cloud-based experience. Well, you have in here the files that the device has. Those files are the configuration file for the containers. It has the same 3 containers here. The VSP, that is the board specification, where is the kernel, the drivers, and everything that the board needs to run, basically. And it has the Pantavisor in here. That is the base of the system. Is this init supervisor, that is the one that runs all the other containers using LXC. We have, this is now how we describe a container in Pantacor, for Pantavisor to be more accurate. You have a source JSON that defines from where the container was built, because we have several ways to build a container. Could be from Docker, could be from a root file system, from another Pantavisor schema. Those 3 basically are the 3 types of container that we can build. This is a normal Docker container. You can see the Docker from where it's built, the Docker tag that is using, and so on. This is the Docker configuration. Then you can see the squashfs of the whole file system. The run JSON is a specification for Pantavisor to set what volumes has, what is the root volume that is going to run, but this is automatically generated by PBR, and you can change it if you are more skilled with the old Pantavisor ecosystem. But for now, this is going to be automatically created, and it will mount any volume that is defined on Docker. And we have the LXC configuration that same way is automatically generated by PBR. And basically this is a container definition, and all the files inside the device are container definitions. And this is the whole state of the device right now, with all the SHA versions of the files that it had inside, basically. If we pull the SD card, we are going to see a storage folder that has all these files with this SHA name. Then we have the device configuration, where we can set up a configuration like, I don't know, Tailscale, for example, has a flag in order to enable Tailscale or disable Tailscale, and we can edit that here. The user configuration or user meta is a full string. In here we can put whatever we want, and depending on the platform, that will mean different stuff. For these enabled sub keys, most of the time they are true or false, basically. Right now I put this user meta, but it won't mean anything to the device because the device doesn't have Tailscale installed. Therefore, I'm going to remove it for now. I was just trying to explain a little bit about everything here. We have the releases of the versions of the device that we have push inside, and we can have a lot of revisions inside a device. And then inside the logs tab, we are going to be able to read a full output of the logs on inside the system. That will include all the platforms that are running, or the containers that are running, and the Pantavisor itself logs that are this in here, that give you the output about what is the state of the device, if the containers are running, and all the information about the system itself. Then inside every platform, let me filter only by AW Connect, we will have basically 4 logs, but could be more. 2 of them are the ones inside the bar log folder, where a Linux system save the logs of whatever is running inside via system control, or any process that is directly logging there. Then we have the LXC console log, that is basically the output of the container, in a similar way of what when you do a Docker run and you start to see the output of the container. That will be like the console log, and the LXC log are logs related to the LXC itself, basically. Then, well, we have LXC console, that is the output of the container, and the messages are the logs from the system, and we can see like the kernel, network manager, and all the process that are running inside the device. And with that, we are going to have the ability to merge like 2 outputs to try to make sense of that and read what is going on in time. Like, okay, here this tried to update, and the console output was this one, and try to figure it out on the book. If we have some problem, the logs are going to be useful for that. And well, we can clear the whole selection, select one, and all the subsequent folders inside. And well, basically that is what we can do with log. With that, we can say that we had a device that is working, that it finished the first boot sequence, and now we need to continue and add the tail scale and the configure tail scale and everything else. But we have a fully functional device using Hub now.